Hello everyone, welcome back to my channel. Today let's go over a medium level question that I just solved on my own. So I'm super happy about this and I'm very glad that I was able to come up with my own solution to this problem without any help. So let's go over it and let me show you how I did it. So this is 743 network delay time. So you're given n nodes labeled from 1 to n, and you're given a list of times. Basically, you have a source and a destination and the cost. And you want to return the minimum time it takes for every node from 1 to n to receive the signal starting from k. So, and then if you can't, return -1. Cool. So let's just go ahead and first build the graph. So we get a default dict of type list. And for source, destination, and cost in times, let's go ahead and attach to the values, the cost and the destination. And so this is a pretty classic Dijkstra-Greedy algorithm from the wording. So let's go ahead and build a queue, and let's go ahead and append, or we can just put in k and 0, because to reach k it costs 0 because we're already at k. That's the starting node, right? And then let's heapify our queue, and then let's just return all the results, because what we're going to do is as we build, we're going to encounter costs, and then the last cost at the end is going to be the minimum because of the way we're sort of popping from the queue based on the cost and then k. So let's adjust that. Cool. So now let's keep running the algorithm until the queue is empty, and then we have the cost and the node, and we're going to pop from the queue, basically sorting by the cost and then the node. So the cost takes the priority. And then again, let's keep track of a set called scene so that we don't have duplicate nodes. And then also, basically we need a target from 1 to n plus 1, because we're going to want to see how much progress we made, and we're going to return the minimum time it takes until we've seen every single node at least once. So let's go ahead and attach a set called progress. Let's call this progress equals set. Cool. And then let's also call this progress, because if progress is equal to our target, then we can print the cost, right? We've reached the destination. And if node is in scene at any point, again, to avoid infinite loops while we explore layer by layer, we're also going to add our node into the scene set right after we evaluate the current progress up to the current node and the best progress. So let's go ahead and explore this node's neighbors, and then we're going to push onto our queue, again, the cost plus the neighbor of 0, because that's what we defined it as in the values of this key in this dictionary. And then we're also going to push our node itself, which is neighbor of 1, the destination node that we can reach with this cost. So, and then also our progress after we add neighbor of 1. So we have to add that node so we can compare them to see if we get the correct answer, right? Okay, let's run this. Okay, so nothing's printing. Target is set range from 1 to n plus 1. And let's also say we're starting from k. Cool. So this matches what we get. Output is 2. So then we're just going to append the cost, right? And then basically that builds it all the way up to the last cost is going to be the one that we want, because it takes all n nodes to receive the signal. So at the end, return result if result else -1. We're going to return the last one, right? Result of -1. So if we print our results, or we print our queue, that matches what we get. So you can see in the first node, we're always prioritizing the cost, and then we're comparing this target. So yeah, so the last one is going to be of time 2. So let's go ahead and submit it. And there you go. Passes all test cases. So again, I'm super happy that I was able to come up with my own solution to this question without any assistance and solve it completely on my own. So that's it for question 743.